Under the theme of designing a piping system, I would like to explain the basics of a piping system. This time I will explain about expansion tanks and pressure distribution in the pipelines, which are essential for closed-type circuits. The contents to be explained are shown on the slide. Expansion tanks. Purposes and functions of expansion tanks. What is essential for closed-type circuits is to absorb expansion and contraction due to temperature change of the fluid in the circuit, keep the pipelines filled with fluid, and keep the pressure in the pipelines positive. Expansion joints are used to absorb expansion and contraction due to temperature change in the pipelines. Similarly, the fluid in the pipelines also expands and contracts. If you do not consider what absorbs expansion and contraction of the fluid, the pipelines and equipment will be damaged. Some of the purposes and functions of expansion tanks are as follows. 1. Expansion tanks absorb the expansion caused by the temperature increase of the fluid in the system. They, therefore, prevent any increase in pressure which would affect portions of the system. 2. Expansion tanks also keep the pipelines filled with water. 3. Expansion tanks maintain a constant pressure to prevent troublesome air from entering. In regards to subheading 1, as the temperature of the fluid in the circuit rises, the fluid expands. Closed-type circuits do not release expanded fluid, so if the fluid is left as is, the pressure in the pipelines increases. If the condition of the fluid is left, the pressure in the pipelines is increased. Any pressure exceeding the pressure capacity of the equipment and valves leads to their breakdown and causes water to leak from the fittings. In regards to subheading 2, if the amount of the fluid in the pipelines drops due to leakage from the pump shaft bearing, the fluid is resupplied by the expansion tanks. If the pipelines are not always filled with water, the air trapped in the pipelines may disable pump operation and cause pipe corrosion. In regards to subheading 3, if the pressure in the pipelines is negative, air comes in from joints and other parts, and the air trapped in the pipelines may disable pump operation and cause pipe corrosion. The air which has invaded the pipelines must be discharged from the circuit as soon as possible. You must prevent air from entering and ensure you maintain the pressure necessary for air discharge. Pressure increase by fluid expansion. Purposes and functions of expansion tanks represented by subheading 1 are as follows. The following equations are used to calculate changes in pressure due to expansion. You should refer to the various tables relating to fluid properties. Example: suppose that the temperature has risen from 10 degrees to 30 degrees. By reading the following values from the tables, you can see that if you calculate using these values, the pressure will increase to 8.6 megapascal. This value is significantly over the pressure capacity of the equipment, pipelines, and valves. The expanded fluid, therefore, must be discharged from the system using expansion tanks. Selecting expansion tanks. How to use expansion tanks. There are 2 types of expansion tanks. One is open-type expansion tanks, and the other is closed-type expansion tanks. Which type of expansion tank is to be used depends on certain conditions. In general, however, select one based on the following cases. Closed-type expansion tanks are used in any of the following situations. 1. If expansion tanks cannot be installed at a position higher than the top of the pipelines. 2. If air conditioners are small. 3. If freezing may occur in cold districts. 4. If expansion tanks are used for a hot water heating system. Otherwise, open-type expansion tanks are used. Calculation of expansion. The quantity of expansion in the circuit should be calculated to determine the expansion tank capacity. The same calculation is used for both open-type and closed-type expansion tanks. A. Calculation of the quantity of water reserved in the system. For calculation of the quantity of expansion, the total water volume in the system is calculated. The quantity of water in the pipelines is determined based on the respective length of each different sized pipeline and the water volume specified in the table. You should get the water reserve quantity levels of each type of tank by, for example, asking their manufacturers. B. Calculation of expansion. The equations to calculate fluid expansion are shown on this slide. For necessary values including the water density and specific volume, please refer to EC data and various relevant books. Design of open-type expansion tanks. Dimensions of open-type expansion tanks. The dimensions of open-type expansion tanks are shown on this slide. These dimensions are extracted from EC data, engineering data, and designs of open-type expansion tanks. For further details, refer to that data. Equations need values represented by the letters A through G. The particular values, except D, are shown. The value D must be determined based on the quantity of expansion as described earlier. Design of closed-type expansion tanks. 1. Function and work of closed-type expansion tank. A common closed-type expansion tank is a diaphragm-type expansion tank. It has an expansion chamber and a pressure chamber. The two chambers are divided by a diaphragm. It acts as shown on the slide. When the expanded fluid enters the tank, the diaphragm is transformed. After the fluid contracts, the diaphragm returns to its original shape by the pressure of the entrapped air. The diaphragm also lifts the fluid to the top of the pipelines when operation is stopped. 2. Calculation of capacities of closed-type expansion tanks. The same method of calculation of the quantity of expansion is used for both open-type and closed-type expansion tanks. Methods of calculation of tank capacities, however, are significantly different between the two types. For closed-type expansion tanks, you must set values including pressure. The capacity of a closed-type expansion tank depends on where the tank is set, the maximum allowable pressure, and the set pressure of the safety valve. The capacity of a closed-type expansion tank relates to the pressure distribution in the tank. I just showed you the equations used to calculate the capacity. I will explain it later in this section about pressure distribution in the pipelines. You can find the contents explained thus far in EC Data, Selection Methods of Expansion Tanks and Engineering Data, Designs of Open-Type Expansion Tanks, and those of Closed-Type Expansion Tanks. 2. Pressure distribution in pipelines. Purposes and functions of the pipeline pressure distribution graph. After a pressure distribution graph of the pipeline system is prepared, the graph is used to decide or check maximum allowable working pressure, to confirm pump back pressure, and to make sure that there are no negative pressure points in the pipeline system. In many cases for such graphs, positions or heights are plotted vertically, while pressure values in the pipelines are plotted horizontally. When you consider the conduits for a district heating and cooling system, you may plot pressure values vertically and horizontal distances horizontally. You probably have seen a pipeline pressure distribution graph like that shown on this slide. Pressure distribution in pipelines when open-type expansion tanks are installed. Pressure levels in the pipelines are different between open-type expansion tanks and closed-type expansion tanks. First, I will explain how to create pressure distribution in the pipelines and how to create distribution graphs. A piping model is shown on this slide. Now I will explain the procedure used to create a graph. The first step is to draw a baseline. The second step is to plot expansion pipe connection points on the baseline. Next, calculate the pressure values on individual connecting points during pumping operation, and plot them on the corresponding coordinates on the distribution graph. Drawing the baseline. Next, let's draw the baseline. The standard height is the lowest point in the pipelines. In connection with the surface of the water reserve in the expansion tank, while at least 20 to 30 kilopascals of pressure should be applied between the top of the pipelines and the air vent valve, the water column height should remain between 2 to 3 meters from the top to the bottom. Pressure in the pipelines at an opening to the atmosphere is 0. The height of the water surface in the expansion tank, therefore, should be plotted. At the lowest point in the pipelines, hydraulic head pressure should be applied to the pipelines. Now the height of the water surface in the expansion tank is 24 meters. The pressure at the lowest point in the pipelines is 235.2 kilopascals. By connect the plotted coordinates, this creates the baseline. Plotting expansion pipe connection point. Let's plot expansion pipe connection points. In this piping model, point A is a connection point. Point A is at the lowest position in the pipelines. Pressure in the pipeline at that point is 235.2 kilopascals. This connection point is considered the reference point of the pressure distribution in the pipelines. Pressure at the reference point does not change even if the pump stops. In addition, even if you change the lifting height and the flow rate, this reference still remains as the reference point because the point does not change. Determining pressure values at individual points in the pipelines during pump operation. Let's calculate the pressure distribution during pump operation. Point A is the reference point. Pressure in the pipelines will not change. First, calculate the pressure at point B1 in the pipelines. That is, since the pump is between points B1 and B2, the pump increases pressure. Then add the pressure caused by the lifting height. Subsequently, calculate the remaining pressure values at other points in accordance with the course of fluid flow. You will find that the fluid returns to point A with the same pressure as the total pressure. Note that, if the height of the pipelines changes, hydraulic head pressure also changes. Plotting pressure values in the pipelines during operation and preparing a pressure distribution graph. Let's plot pressure values at individual points. The pressure distribution graph of the pipelines is shown on this slide. The maximum allowable working pressure is 530 kilopascals in the pipeline system. This system has no negative pressure. EC data describes what happens to pressure in the pipelines if an expansion pipeline connection point is changed. The normal pipeline expansion connection point is on the suction side of the pump. Pressure distribution in pipelines when closed-type expansion tanks are installed. Calculating expansion. Let's calculate expansion. Necessary conditions are shown on the slide. If you calculate it, you will get 84 liters of expansion. Setting the minimum required pressure of tanks. Here, let's set the minimum required pressure of tanks. You should calculate it regarding the expansion tank connection point as point A. As explained in open-type expansion tanks, the minimum required pressure is the pressure obtained by the addition of the pressure in the expansion tank, the pressure applied to the top of the pipelines, and the pressure applied to the air vent valve. The minimum required pressure is also an absolute pressure. Subsequently, add 101.3 kilopascals of pressure equivalent to the atmospheric pressure. The minimum required pressure for the tank is 317.3 kilopascals. Setting the maximum allowable operation pressure for tanks. Now, let's set the maximum allowable operation pressure for tanks. The maximum allowable operation pressure is determined by the maximum working pressure of the system obtained by the maximum working pressure, etc. of the equipment, the set pressure for the safety valve, and the install position of the safety valve. Here the safety valve is installed at point C1. Considering the maximum working pressure of the equipment, 700 kilopascals is used as the set pressure. After calculation, the maximum allowable pressure for the tank is 536.3 kilopascals. Determining the pressure in the pipelines during pumping operation. Let's calculate individual points in the pipelines with the same procedure used for the calculation of pressure in the pipelines in open-type expansion tanks. For calculation, the minimum required pressure of the tank is used as the pressure at the connection point. Results of the calculation are shown in the table. Preparing pressure distribution graphs of pipelines. Let's prepare pressure distribution graphs of pipelines. A prepared graph is shown on the slide. This distribution graph shows one after water has contracted. As for open-type expansion tanks, I explained that pressure in the pipelines does not change. However, for closed-type expansion tanks, the pressure in the pipelines changes upon expansion and contraction. During expansion, pressure of the expansion tank connection rises to the maximum allowable operation pressure of the tank. The pressure of the tank connection point A rises to 435 kilopascals of the maximum allowable operation pressure of the tank. Where the safety valve is installed, pressure is the set pressure of the safety valve. This means that pressure in the pipelines changes upon expansion and contraction. If such change increases pressure in the pipelines, the safety valve opens and water is discharged from the system. If water is discharged, it is resupplied during contraction. Air is blended into the resupplied water, so you should make every effort to not resupply water. The set pressure and the expansion tank capacities, therefore, are important. Calculating capacities of expansion tanks. We have already set the values necessary for calculation of tank capacity. Let's calculate capacities of expansion tanks. As a result of calculation, the tank capacity is 230 liters. The stopping of incoming air due to defective expansion pipe joints. The description of pipelines in engineering data contains the stopping of incoming air due to defective expansion pipe joints. At first, their purposes and a summary is described. As the first item, 1. To be confirmed, the material also instructs you to check whether negative pressure is applied to the pipelines or not, while it describes the standard connection points of expansion tanks and expansion pipelines. Be absolutely sure to follow those instructions and standards. The material includes information regarding failure resulting from insufficient tank capacities, so please comply with the selection standards. The second item, 2, includes some reasons why resupplied water should be as little as possible. This is the end of the explanation of expansion tanks and pressure distribution in pipelines.